Okay, hello, my name's Dr. Randy Price, and I want to show you something today that's a little bit more high level with the Agisoft software. I know there's times when you'll load multi-spectral data, like from the Sequoia camera, and you'll end up with like 4 different layers or 4 different bands. Like you could have a red edge, NIR, green, and red, and this would apply to newer cameras that they're starting to make that have multi-wavelength bands. One of the problems with that is when you put that in the Agisoft, you'll get a multi-spectral type image that can be saved as a TIFF. And it's hard to save it as a JPEG because JPEGs really are the standard image format for computers from way back when, and they really only contain 3 bands. So what we're going to show you here today is how to disassemble that into different layers, save those different layers, those different wavelengths individually, and then reassemble them into a composite or RGB type image, which you then can show or analyze with most different programs that are on the internet. And this may be helpful if you're trying to just get the NIR and the green or the red wavelength out. You don't care about the other ones, and you just want those in a composite type image to do analysis with. So that's what this lesson will be over today. So let's start Agisoft. This is a program that we typically use. You could probably do this with other programs, but this is the one we use. And to remind you again, what is Agisoft? Well, this is a program that will take individual photos from drones or UAS vehicles, and it will put those images back together. And we have if you look at some of the previous videos, it'll show you how to do that with the Sequoia camera and some of the other things. So let's go to open a project that we've already done. Let's go to desktop. This 0.025. This is one that we'd already done where we took some Sequoia camera and we flew a field, and then we put the images back together. And if you go to the Ortho Mosaic, you can see this right here. Now, if I was to save this from this program, since this has 4 bands in it, this is not something that I could get into a different, a standard Windows program like picture type program very easily, and that could cause me some problems. So, so if you want to get that into a standard standard type program, that's what we're going to go over. So if you go to the little Picasso painters thing here, you can see that this has 4 different wavelengths embedded in it: green, red, red edge, and NIR. So what we're going to do is show you how to disassemble these, save these as individual wavelengths, and then reassemble those using ImageJ to have a composite or a 3 wavelength image that you can use in most all the programs that are available on Windows. So, okay, so let's start with the NIR because you're probably interested in that because most of these high-end cameras, this is the one added wavelength they have. So we're going to delete this, double-click on that. We're not going to put anything else because we're not really doing a calculation here. We just want to save the single band, do enable transform. Make sure you do that. We can hit apply. Now this may be all black or white or something like that. And in mine, I've already done it once or twice, so that's why you see the different levels. So then go over to the palette. Make sure you hit this. You don't have to every time, but this redoes the histogram. Now, I like to pull these all the way out, okay, to the edges. And what that's going to do is that's going to save my data, you know, from the lowest minimum value to the highest value there was. And this is a, you know, the Sequoia camera saves in, I think it's 10-bit or maybe 12-bit, I can't remember which. But this saves values that range from usually 0 to 65, 655, I think, or something like that. So, you know, this isn't standard 8-bit data, 0 to 255. This is, you know, now 10-bit data or higher. So that just means that you have more numbers, more graduations. To tell you the truth, I've played with 8-bit data, 0 to 256, and compared it to this data, and really I seem to get similar results with either one. So we haven't reached the need for that sensitivity yet, although it's kind of nice that it's there just in case you do need it. And in the future, you know, as things get more sensitive, it may become crucial. But right now, usually 8-bit data works fine for me, or 10-bit, whichever. They both give nearly the same results. So hit OK after selecting this. And now we have the layer that is just the NIR wavelength by itself. Okay, so from here I go and I hit export ortho mosaic, because I'm going to export this whole thing. I'm going to select JPEG when I get there. Don't do it. Well, you might be able to do a TIFF. I always do JPEGs. Then hit NIR or some name that's indicative of the single wavelength. Make sure you're in the right directory here. We did go desktop 005, so we're in the right one because it may have saved, you know, you may be in the directory that you saved from last time. Okay, hit save. Alright, so if we go to that directory, here's that directory right here, and we scan down, you know, and these are all the little images that were put together to make this one big composite image. We should have a new image somewhere in here. Oh, hang on, I may be in the wrong directory. Yeah, sorry about that. We want to go this directory. Okay, let's look in here again. Okay, so here is that image. Now when I click on this image, it comes up in like your regular Windows type picture programs, which is kind of nice. So I've got this here. This is really just the NIR values in black and white content. Okay, so let's minimize this. Now if we're going to make a composite image, that always has 3 bands. You know, usually it's red, green, and blue. But we could put in NIR for the red or whatever. So let's make a couple more so that we can do a composite image. So let's go back to the Picasso thing here. Let's do the red this time, because when I reassemble this, I'm going to do NIR, red, and green, because those are the wavelengths I may use. Like in corn, I may want NDVI with the green wavelength, and then in you know, some other crop I may want NIR red. So those are usually the 3 important ones to me. So let's put B2 in here. Hit apply. You can see it changed colors. It got a lot darker red. Now do note, I've seen this before with the Parasequoia camera, and it's a little bit hard to adjust. The reds are pretty deep, so they're pretty dark and low in value. Sometimes I don't like that. I'd like to see a little bit more sensitivity, but it kind of sets that up the way it wants it. Go over to the palette. You can redo this if you want, but we'll let it stay the same range as last time. We'll hit OK. We'll go over here, export. We'll pick JPEG again, and this time I will put red for the red band. And you can see the NIR one is still there. Hit save. Now if we go to that, there we've added in a red wavelength, or red image, which is the red wavelength. Okay, so we need one more, because we're going to make a composite image in Image J. So let's pick the green one. So let me delete that. You can either put in B1 here, or just double click this, hit apply, and there's the green wavelength in black and white color. Now one thing I should mention, over here in palette, if you don't see this in black and white, when you're over here in palette, you may have to change this. Like, here's the heat scale, and if we hit apply, we get that. You want to save this in grayscale, because that's going to save these numbers here. So hit apply right there. Okay, we still have the same range we had before. I hope that -32 doesn't mess it up. You could put 0 here if you wanted. And then let's hit OK. So then we save this one last one. Export, JPEG. And then we're going to save this as green. Okay, so now if I go over to my folder again, oops, wrong one. And I killed it, so I got to go back to it. If I go to this folder again, here's the green. It's up here on the top because it starts with a G. The other images started with I's. Down at the bottom, we have the red one and the NIR. So we're ready to assemble a composite image from the different wavelengths bands that were in this image. So now I'm going to kill this program. You could save it if you want. Usually I don't save that part because I had some other indices I like, calculation that I did in it, like NDVI or something like that. going to go over the Imagery. Start that program. You can see my other videos, the earlier ones, on how to get this program downloaded and find this program. This is a free program available on the internet that you can pull down. It's very good for scientific type work, and you know, it's a freeware type program done by scientists. Okay, so we're going to open those images up, and do remember that these have to be of similar size images. You can't really take different size images and do this process and put them together. So these images really had to come from the same camera. Okay, hang on, I'm still in the wrong folder. I've got two different folders with that 025 on it. So let's go to the desktop. Right here. Okay, here's the green one. So let's open that one up. There's that image. Now, depending on the size of your computer, this is a this is an orthomosaic that was made by a bunch of different images put together. These can be quite large. So if you have a computer that may be slower, you may have to wait a little while for this to come into Imagery. Just give it some time because it'll get it in. And if it's taken way too long, then it may be time for you to upgrade to a different computer. You can see the LSU Ag Center website. We have some under technology. We have some different papers on how to build a good computer, for this purpose, and what you should put most of your resources in to get a computer that can do this process fast. You can look over there for that. But I will tell you, gaming type computers are real good. Put all your money in the processor because that's what does most of the calculations for these type of endeavors. So, okay, well, let's open the other three up. We'll need the other three because we're going to reassemble these. So here's the red one. There it is right there. Note these images are exactly the same size and same orientation, pixel for pixel, because they came from the same camera that took them all at the same time. And let's open the last one up, the NIR. Okay, there we go. And you can see the NIR is definitely light. That's usually what happens is if you have foliage, this value is lighter, and it usually works in the opposite of red. Red is darker where foliage is because it's being absorbed by the foliage, which is good. Red is what's getting used by the chloroplast and photosynthesis to make things, starches and things that the plant can use and grow. So usually the red image is darker. The NIR is like a reference background one, that relates more to non-foliage. So it's kind of like a standard background. And a lot of times they use the NIR in the red or the green in NDVI type calculations, which are related to plant health. Okay, so now we're going to go to image. We're going to go to color, and we're going to go to make, oops, sorry, man, the wrong one. Merge channels. When you go right here, this will allow you to take some different images. We're only going to do 3 because I want to be able to save this as an RGB, which will be loadable by most Windows type programs. Makes it a little bit easier for me to use, showing papers, things like that. So you go to this merge channels under the image, and you'll be able to select each one. Now note that a standard red, green, and blue is red, green, and blue, but we're going to rearrange this because we want these 3 colors to be NIR, red, and green. So we're going to make what might be called an NRG photo. So let's put the NIR in the first one right here. Then we're going to put, let's go ahead and put green here just so it matches. So this will be at NGR. And then we're going to put red in here because these are the 3 wavelengths and 3 colors that I might calculate things from. I may not want to use blue. I don't care about, maybe I have some other source like thermal or something, and, I'm not using that or whatever. So, and then we're going to click on Create Composite if it's not already clicked on. So when we hit OK, voila, here's what we get. We get where it took those 3 background images and it combined them into one RGB image. But this really isn't RGB, this is really NGR, which will be near infrared, green, and red. So you have to remember that because Windows will think this is RGB, but it's not, it's NGR. So So if you do calculations with this in the future, you have to remember that the red is really represented by the green. So you might want to save it under a name or something that tells you that, so you don't forget. Next, we're going to save this. Save it as a JPEG, TIFF, whatever. Usually I do JPEGs because they're things that can be put into papers real easy, and they're not hard to mess with. Let's make sure we're in the right directory. Desktop 05. Okay, and let's give this it says composite, and we're going to give this the wavelengths that we use. We know it's going to be an RGB type file, 3 wavelength that Windows is normally used, but this is going to be called NGR for near infrared, green, and red. And we hit save. Okay, so if we kill this and we go to that folder, we will find out that we have a new image, and this is this composite NGR. Now I can click on this, and now this one will come up in Windows, and I have my near infrared, my green, and my red all in one image that I can do things with. Like I could say edit and create, things like this, with most regular Windows programs. I don't need a special program to mess with this. Okay, so let's go back and just see what that looks like. Let's reopen this. Okay, there's that composite image. And see, it thinks it's an RGB, but really this is near infrared, green, and red. So if I was to highlight a little area of this, and I hit Analyze Histogram, I've showed you how to do that in some of the other photos. And let's hit Live, so that when I change this, that'll change. Let's go to the red one. Here's the red. Really, the red is NIR. So we would expect places like this. The median there is 97 versus places like the road. It's a little bit higher. Okay. Now let's check on the green. This is the green. So you can see this is 53. And remember, this value is range. This is 8-bit, so it ranges from 0 to 256. 256 is the highest value, and 0 is dark. So let's go over here on the road. You can see it's higher there. So I don't know what that means. It just tends to be higher. Now blue is not really blue. Blue is actually red in this case. So in here, the foliage ought to be really low because it's absorbing that wavelength. And we look, this is 29. This is corn here. These are like corn plots for one of our entomologists. And there is differences here where he was doing different things with fungicides and testing how well they work or don't work. But you can see that this is pretty low, 29. So let's see what the road looks like, which is dirt or soil. You can see here, this isn't really blue. This is the red wavelength. You can see it's much, much higher. It's reflecting a lot of the red. It's not absorbing that. So you can tell that everything worked right. So now you have an image that in our previous Agisoft lessons, I showed you how to get raw numbers for this. You know, these little mean numbers, and be able to do your test plots. Like this might be one of your test plots. And now you could go in, and without changing this box, you could get the blue, which is really the red, the mean of the red wavelength for that plot. You could go over here to red, which is really the NIR or near infrared wavelength. I could get the mean number of that, which is 110. I could plop those numbers into Excel, and then I could calculate the normalized difference vegetative index, or the NDVI, based on red. I could also get the green number and have NDVI green, which, you know, we found works pretty good in corn at times. So this is a way that you can reassemble that Parrot Sequoia data into something that you can then get your values out with ImageJ or other, you know, more regular type Windows programs. Now do note, you know, for people who are higher end, if you don't want to do this process, or, you know, say you don't know anything about ImageJ and you're more into GIS and you have some high-end GIS programs, you know, you may be able to work with that multi-band photo or image in those. But this is one way, you know, I've done this with programs that I regularly use, that makes it easy for me. And I can show this really easy in other Windows programs like Word and stuff like that. Okay, well, if you got any questions, you're welcome to give me a call or send me email. My email address can be found on the LSU Ag Center website. We're always available to answer questions and things like that. Okay, thanks. Bye-bye.